So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 13 of the June daily Leetcode challenge, and we again have a medium level question in front of us. It's a very nice question and a tricky one. Let us see what the question is. We are, as you can see, given a matrix here, a 2D matrix, which is called grid in this case. This is the only input going to us, and the output will be integer. So is that integer? How to get it? Let's see then the question. So what we are given is we are given a zero index and cross n. So it's a square matrix essentially. Okay, integer matrix grid, return the number of pairs. Okay, I have to return the number of pairs. Okay, they are saying ri comma cj. Okay, such that row ri and column cj are equal. Okay, that means, for example, the first row and the third column, if they are equal, that means it will add a count to my number. Okay, it will add a count to the final answer. That is how it is. Okay, we will come to that. We will come to that in details, but let us complete the question first. A row and a column pair. Okay, a row and a column pair is considered equal if they contain the same number of elements in the same order. Okay, so see, they have just said are equal. Okay, but what is the definition of equal? A row and column pair is considered equal if they contain same elements in the same order. That is an equal array. Okay, let us see some examples here. For example, see, first row is 3 to 1. Okay, that is fine. 176 and 277. Okay, now let us see which row matches with what, which column. Okay, which row matches with which column. Okay, so for the first row 3 to 1, you can see it is not matching with any column. 3 to 1 is not matching with any column. Come to second row 176, you can clearly see it is also not matching with any column. Okay, come to third row 277, we can see that it is matching with second column. Please follow the mouse pointer here. 277 is the third row, it is matching with the second column. Okay, that's what is mentioned here, row 2. And so basically that following a zero index way. Okay, so basically this will be the second row and this will be the first column. Okay, because the first one is zeroth column. Okay, so this is what is matching. Okay, and you can see 277. So whenever a single row matches with a single column, it will add one to the count. Okay, one to the final answer. In this case, only one row is matching with a column. Okay, so the final answer will be 1. Now come to the second case. Here we are having a bigger grid, that is a grid of length 4. It's again a 2D grid. So here again we have to find a similar thing. Okay, you can trace it for yourself when these are the answers given. Okay, they are saying that row 0, okay, 3122 is matching with column 0. Okay, 3122. Okay, row 0 matches with column 0. Then comes row 2. Okay, 2422. You can clearly see it matches with this row. Okay, it's the second row and the third row. Okay, column 2 2422 matches with row 2 and row 3. Okay, so that is what it is. Yeah. So column 2 matches with row 2 and row 3. So that's why our total answer is 3, because ultimately we have to count a single row matches with how many columns. For each thing it will be a different count, right? In this case you can see column 2 matches with row 2 and row 3. It adds in a different, see, the counts coming out different. Okay, they will not be counted as 1, they will be counted as 2 for this case. Okay, and row 0 and row 1. So the idea here is, whenever a single row Ri matches with the column Cj, it should be adding, contributing 1 to the final count, which is the final answer. So there are many ways to do it. See, you could have done it using the brute force approach also, going through each row and column and doing it that way. But if you do that, it will take O of n cube approach. Okay, because essentially you will have to go through each row, and for each row you will have to go to each column. That's how it is. It will be around O of n cube approach, but we do not want that. We want a bit faster approach. So in my case, I am following the hash map approach. Okay, we'll see how it works. So first of all, I'm extracting n from the grid given, because I know it's an n cross n grid. So I am taking along one direction. Okay, you can take along only one direction. I am taking along the vertical direction that I'm calling as n. Okay, then I'm declaring a dictionary, which is a mapping basically. I'm calling it rows. Okay, because I will be storing the rows here. Okay, so then what I'm doing is I'm going through each of the rows. See, for I in grid, okay, if you see like this, it basically means I represents each of the rows. Okay, I'm not moving in two directional way, I'm just moving one direction. That means I am going through each of the rows. Okay, for I in rows, I represent each of the rows. I initially will be, as you can see, in the form of a list. Okay, I in the form of a list. Remember, list cannot be hashed. Okay, because lists are changeable. Okay, they are not mutable basically. So what I'm going to say is, see, something which can be changed cannot be hashed. Okay, because for hashing you need constants, right? That is a very simple logic. For hashing you need constants, and lists are not something like that. Okay, that's why I need to convert it into a tuple. Tuple basically means tuple is basically similar to that of list, but the only thing is that you cannot modify it after that. Once a tuple is made, it cannot be modified. Okay. So that is the basic idea. I'm just creating a new tuple A out of that. For each row, I'm converting it from a list to a tuple. Okay. Then I'm checking basically. See, this is the dictionary, as you know, so it will be having key and value pass. Okay, so each key will be basically a row in this. Okay, each row will be key in this, and the value will be number of its occurrence. Okay, its frequency. For example, A is a tuple. See, A is the row. I'm converting into a tuple. Now it's called A. I'm checking if A is in rows. If it is not in rows, it will come here. Okay, I will just make it a key and I will add the value 1. Okay, if A is already a row, that means A is coming for the second time, right? So I am just increasing its count. Okay, that means I'm just updating its frequency. That is what it is. Okay, I will just quickly print how this output looks. I will just quickly print and show you. Then it will look very clear to you. So you can clearly see this is for the second example. Okay, so you can clearly see the row number. This third row and fourth row you can clearly see they are same. Okay, so this is how this becomes a key and its value becomes 2 because it's present 2 times. Okay, and if you see the other rows, okay, 1445 is present 1 time, 312 is present 1 time. Okay, so that's how it is, getting populated. So this was all about it. I will just comment it out again because we don't want it to be there in a final answer. Now starts the final answer. Okay, so from now I will going through each of the columns. See, till now I went through each of the rows. I recorded it using, I basically captured using a tuple. Then I saved it in my hash map with its counts. Okay, how many times it is present. Okay, now I'll be going through each of the columns. Then I will be checking if there is any match or not. Okay, so this is the final answer which you're going to return. I'm initializing it with 0. Okay, for I in range n. Okay, this is going to be my column. For j in range n. So basically we are trying to see, for example, I am going to collect all the elements in the first column. Okay, that's what I'm doing here. Basically, this is just a part of that. Okay, this is how I'm gathering all the elements in the first column. That is the 0th column. Okay, so the column I'm initially initiating like this. Okay, then I will updating all its elements. That is all the in all the rows the first one will be captured and they will be updated here. They will be appended here. Okay. Finally, now call is ready. Okay, my call, which is basically representing the first column, is now ready. I will, as you know, it's in a list form. I will convert it into a tuple because see, in Python you have to understand this, or basically in any hash map for that reason, you cannot hash something which is changing. Change, it can be changed something, then it cannot be hashed. Okay, for that you require constants. Constants are the best way to where we can hash. Okay, that's what we're doing here. I've contained a tuple. Now I'm calling it a B. So B is basically a column now. Okay. I'm just checking if this particular B, which represents a column, is already in rows. Rows where it we witnesses. Here is the rows. Here is the rows. I just to remind you. So I am checking if this particular column which represents B represents each column one by one. Okay. It will first represent the column 0, then the column 1, and so on. Right. So I will just checking in each case if it is already present in rows. If it's present in rows, then what is the count of that row? Okay. For example, 2 for 2 is present 2 times. So if something matches it, basically it will contribute to the final answer as 2. Okay, its contribution to the final answer will be 2. That's what we're doing here. I'm just updating my answer with the frequency of the row with which it matches. Okay, and then like this it will return for all the columns, and finally I'm returning the answer. I'll just quickly run and show how it works. You can see it matches. Okay. It's clearing all the test cases. This is nearly 70 to 80% faster. And see, it's if we talk about time complexity, it's going to be O of n square. Okay, and space complexity is also obviously it will be similar because we are storing the whole rows, and we are matching it. Okay, when we are storing all the rows, which it obviously means we're storing the whole grid, so it's obviously going to be O of n square only, right? So see, if you have tried the brute force approach, it would have taken. See, what is the brute force approach? For each row, I will be matching it with each of the columns. So it would have taken for matching it with each of the columns. That's something like this. So that's something like this. That itself will be O of n square. And for selecting each row, it will again be O of n. So around O of n cube. Okay. So instead of going for O of n cube approach, we are reducing it to O of n square approach. Okay. That was the optimization here. If you have a better way of doing it, please let me know. We can discuss it further. But yeah, friends, that was all for today. See you tomorrow again. Thanks a lot.